Good morning, Math 30s. We are continuing on with our study of radicals and rationals, and we are moving on to lesson 2, which is in your note package, and lesson 2 is on solving radical equations graphically. So for this question here, it says, determine the roots of this equation algebraically. And for part A, when they say algebraically, they are referring to what you learned in Math 20-1. So we'll do a quick review of what you learned in 20-1 Math. So let's take our radical. So our radical is going to be root x plus 5 minus 3 is equal to 0. And in 20-1, when you were told to solve this algebraically, what you needed to do was you needed to isolate this radical. So get rid of that negative 3 by adding 3 to both sides, and you would get root x plus 5 is equal to 3. From here, you need to get rid of that square root sign, and the opposite of square root sign is squaring something. So what you do to the right hand or the left hand side, you also do to the right. So then we would simply get x plus 5 is equal to 3 squared is 9. Isolate x by getting rid of that plus 5. So x is equal to, and we would have 4. So our solution is 4. How I could check this, how I would verify this, is if you take this x and you put 4 in. So what we would have is we would have 4 plus 5, which is 9, and we'd essentially have the square root of 9 minus 3 is equal to 0. We know that the square root of 9 is 3. 3 minus 3 is equal to 0. And then 3 minus 3 is in fact 0, and we would have left-hand side equaling right-hand side. So that's how we would verify that our solution of 4 is correct. What B says, B is now getting into 30-1. So B says, using a graph, determine the x-intercepts of the graph of this equation here. So B is saying y is equal to the square root of x plus 5 minus 3. So what we're going to do to calculate this is we are going to type this into our graphing calculator in y1, and we're going to be looking for the zeros of the function. So go to your graphing calculator and go to y is equal to, and let's type in our function. So the function is the square root of x plus 5. Scroll out of your radical sign, so hit the right arrow, and then hit minus 3. So I'm just going to hit zoom 6 standard because I might have changed my window in a previous question. So here's our radical function right here. So it was translated, the k value is negative 3, right? So it's translated 3 units down, and the h value is negative 5, so it went 5 to the left, right? So it was a radical function, y is equal to the square root of x, that has been translated. So this is our function here, and to find the solution, we want the 0. So the 0 is where does our radical cut the x-intercept? So second function, calculate, we're looking for a 0. And the x-intercept is right about here, but it says to go left of the 0, so you want to go below the x-intercept. And then I want to be above the x-intercept. Enter, hit enter again, and I've got x is equal to 4. So I've confirmed my solution, x is equal to 4. One thing I just want to quickly mention, I could have actually changed my graph to see this a little bit better. So I'm going to change my y maximum to be 3 and my y minimum to be negative 3. And then I'll show you that you'll just see that a little bit better. So if I went from negative 3 to 3, and I look at this graph, there we go. I could see that x-intercept much better. And then if I went second function calculate as 0, so I'm looking for that 0 there. So I need to go left of the 0, which is below, right of the 0, which is above, and then enter. X is equal to 4. So the solution is 4, 0. And again, what we're looking for with solutions when it's asking for what the 0 is the x-intercept. C says determine the connection between the roots of the equation and the x-intercepts of the graph of the equation. So this for A, we did the root of the equation and we got x was equal to 4, right? In B, we did the x-intercept of the equation, which is the same thing as the 0, and we got x is equal to 4. So what it's sort of asking for C is, well, what's the relationship between the root and the x-intercept? They're the same number. So the roots or solutions to the equation correspond to the zeros or the x-intercepts, right? So that word roots, zeros, x-intercepts, they're all used interchangeably. So the roots or solutions to the equation correspond to the zeros or the x-intercepts, I should add, of the graph. Okay, let's look at the next question. And I'm going to show you two different methods to solve this. So what they've given us is they've given us this radical equation here, and I know it's an equation because it's got an equal sign, and I know it's a radical equation because there's a radical. So it says use graphing technology to solve this radical equation and give the solution to the nearest tenth. So there's two methods. The first method is actually probably the method I prefer. It's called the intersection method. Okay, so what the intersection method is write the equation that they give you. So the square root of 3x plus 2 is equal to negative 6 plus x. And what the intersection method is you punch this into y1 on your calculator, and you punch the right-hand side of the equal side into y2 on your calculator. And what you're going to have when you type it into y1, you're going to have a radical graph, because that's our radical. This is going to be a linear function, so it's going to be a straight line. And then we're simply going to find the intersection of those two graphs. So let's punch it into our calculator and see what we get. So again, for my radical equation was the square root of 3x plus 2. And then my linear equation was negative 6 plus x. So negative 6 plus x. I'm going to do Zoom 6 standard since I changed my window on that first question. Okay, now my solution is actually way over here. The two graphs are going to intersect. So I do actually need to change my window. Right now my window is going up to 10. So I'm going to change my window setting and I'm going to go up to 20 for my x maximum. And then what I like to do for the scale factor is I always take what my maximum value is and I subtract a 0. So I'm going to set my scale factor to 2. So now when I graph, there's my radical, there's my linear. The solution when you have two graphs, it's the intersection of those two graphs. So second function, calculate. I'm looking for number 5 and intersect. Actually, sorry. Second function, calculate, number 5 and intersect. You get close to your intersect and you simply hit enter 3 times. So enter, enter, enter. And what it says is that the solution to the nearest tenth is x is equal to 12.2. So let's write that down. So x is equal to 12.2. Okay, the second method is as follows. You take the equation that you were given, 3x plus 2 is equal to negative 6 plus x. And what we're going to do for this method, method 2, is we're going to do the 0 method. So essentially, we are going to do what we did in the previous question, where we're going to bring everything to one side of the equal sign, and then we're just going to graph a y1. So what I'm going to do is I'm going to keep the radical where it is. I'm going to add 6, and I'm going to subtract the x. So I'm going to bring the 6 to the left and the x to the left. And what I would get if I do that, I would get the square root of 3x plus 2. If I add 6 to both sides, I'd get plus 6 over here. And then I'm going to subtract x from both sides, and I would get minus x. And then what I have is I have that equal to 0. So this is called the zero method, okay? And the zero method is when you have everything on one side and we get 0 on the right-hand side, what we are doing is we're going to be looking for a 0 on our graph. We're going to be looking for an x-intercept on our graph. So now on my calculator, I'm going to type this into y1, and let's see what we get as a solution. So going back to my calculator, I'm going to clear this, and I'm going to clear this. And let's type in the equation all brought to one side. So 3x plus 2. I always find it's easier to bring everything to the side where your radical already is. And then we needed to add an x. So make sure you scroll outside of the radical. So we need to add an x, and we're going to add a 6, and we're going to subtract an x. So now when I graph this, the solution when you brought everything to one side is you're finding what the 0 is. And the 0 is essentially another word for the x-intercept. So second function, calculate. And we're looking for number 2, which is a 0. So I'm looking for, well, what is that value there? So it wants me to go left of the 0. So hit your left button. Then it wants me to go right of the 0. So hit your right button, and you're going to be below the 0. And then guess is enter. And look at that, we got the exact same answer, 12.2. So x is equal to 12.2. So what I hope you're sort of taking from this is if I give you a radical equation, it does not matter if you say, okay, I'm going to graph y1, y2, if that's your preferred method, or if you're going to bring everything to one side and then find the 0. Either works. I tend to, like, my preference is if I see it written this way, I'm just going to say, okay, you're y1, you're y2, and I would graph that method. And the reason why I would do that is because some students may make mistakes bringing these the -6 over and the x over. And so if you just stick to the intersection method, you won't make that mistake. Next class example, very similar. So what's going to happen for these two, I'm not going to punch them into the calculator. I want you guys to punch them in. What I would do for this is for A, I would do the intersection method. I think that it's going to be the most efficient. So plug that into y1, plug that into y2, and pause the video and then unpause it, and I'll give you the answer once you get your intersection. Okay, what you should have gotten, if you did this correctly, you should have gotten an intersection point of 13,8, and the answer is always going to be the x value. So therefore, the solution, or the root, the solution is going to be x is equal to 13 for that question there. So this is what your graph should have looked like, and you should have had 13 and 8. Try this one here. So try this one here. And again, punch x into y1, which is just going to be a straight line. Y is equal to x. Oh, sorry, not a straight line. It's going to be this linear line down here. That's the equation of y is equal to x. Punch this into y2. Check what your intersection is. So pause your video to get your intersection, and then you could unpause it once you get it. Hopefully you got that the intersection was at 3, 3. So my solution is x is equal to 3. There is no homework for lesson 2. So what we're going to do now is I'm going to give you some diploma questions. So I'm going to continue this video and we're going to do 2 diploma questions together. And these diploma questions are on radical functions. Okay, so let's look at, sorry, 3 diploma questions we'll do. Let's look at this diploma question here. So it says, this is the graph of y is equal to the square root of f of x. So this graph is already a radical function. And we know that generally what we have is we have a standard function, y is equal to f of x. And to transform that into a radical function, what you need to do is you need to take whatever the function is, f of x, and you put it underneath a radical sign. Okay? Now, one thing I want to go through in order to understand this question is, let's say you had a point on the original function and your point on the original function was 0, 25. If I said to you, well, what's the new point going to be on the radical function? We know that with radical graphs, what we have to do is we square root the y values, right? So on the new function, the coordinate would be 0, 5. Okay? Now, what this question is going to do is we're going to be having to think in reverse. So let's just say, for example, I gave you the point 0, 3, and I said that that is a point on the radical function. What was the point on the original function? So to go from original to radical, we have to square root the y value. So to go from radical to original, what do we have to do to this y value? What's the opposite of square rooting? And the opposite of square rooting is squaring. So the original coordinate would have been 0, 9, right? That would be the original coordinate. And this coordinate here is going to be on the radical transform function because the square root of 9 is 3. So me saying that, they give us this graph here, and they say that this radical graph has a range of 0 to 9. So what they're saying is the largest y value is 9, and the smallest y value is 0. Okay, so that's okay. And then what they're saying is the question is saying if f of x, so the original graph, is a quadratic function, which point cannot be on the graph? So what we have to realize is that the maximum point, so let's just say it was right around here, that point there is 0, 9. What would that point have been on the original graph? So we have 0, 9. That point on the original graph, because this is the transformed graph, which is a radical, I hope you see that that point on the original graph would be 0, at 9 squared is 81. Okay? So what that means is the highest point on my original graph has a y value of 81. So if I look at these coordinates, if the highest value of my original graph is 81, which of these values are outside, which of these y values are outside of 81? And it would be this guy here. It would be C. 90 is a bigger number than 81. So therefore, a coordinate of 4, 90 would not have been on the original function because the maximum y value, if I square that 9, would be 81. Okay? Going to this question here. So here's the graph of 3 functions. They call this one f of x, this one's g of x, and this one is h of x, right? So f of x, g of x, and h of x. And then it says each of these functions below are going to be transformed into radicals. So they're going to take f of x, put it underneath a radical sign, g of x, put it underneath a radical sign, h of x, put it underneath a radical sign. What it's asking for is the number of invariant points on the original graph and its transform graph. Okay, so invariant points, what you have to remember for radicals is they occur, so invariant points occur when y is equal to 0 and y is equal to 1, right? So invariant points are points that don't change from the original and the transform graph. So what I need to do for this diagram 1 is I'm going to put dots on all of my invariant points. So I need to look for where is y 0. So this is going to be an invariant point, and that's going to be an invariant point. Now I have to go to my graph, on my original graph, where is y 1? That's going to be an invariant point, and that's going to be an invariant point. So the number of invariant points on the original and the transform graph for this diagram, there are 4 invariant points. If you go to the next diagram, diagram 2, put a a green dot or put a dot at either on the graph, the original graph, where y is equal to 0 or where y is equal to 1. So here's 0, nothing at 0. Here's y is 1. There's an invariant point right here. So that will be a point on the original graph and on the transformed graph. And that is going to be diagram 2 has 1 invariant point. If I look at diagram 3, and I'm going to take the radical of this graph here, what would happen is invariant points occur when y is equal to 0, the graph doesn't cut through 0. Where y is equal to 1, the graph does not cut through 1. So this graph has no invariant points, right? So that answer would be 0. Okay, because if you said, okay, well, this coordinate here, 4, 4, where would that be on the radical graph? It would be at 4, 2. So that point would go and be down here. And so there are going to be no invariant points. Last diploma question that we'll do together. So the graph of y is equal to f of x is shown below. And what it says is when comparing the graph of y is equal to f of x with the graph of the transformation, so the transformed graph. So we've got y is equal to f of x, which is the graph given. And we're going to compare that to the radical graph, so the square root of f of x. The x-intercepts are. So the x-intercepts of the graph would be this guy and this guy. And what they're saying is, okay, the x-intercepts on the original graph, what will these two x-intercepts be on the transformed graph? Well, I hope you realize that x-intercepts are invariant points, right? They're invariant points. Why? Because all invariant points occur when when y is 1 or when y is 0, right? So this point and this point will be on my transformed graph. They are invariant points. So the x-intercepts are going to be the same. Now we have to look at the y-intercepts. So the y-intercept of the graph. Okay, so this graph here, here's the y-intercept, and let's just say that that graph has a y-intercept of x is 0 and y is 6. So 0, 6. Well, what will that point be on the transform graph? It would be 0 and the square root of 6. So on my transformed graph, the y-intercept is going to be different. It's going to be down here. And my graph is going to look something like this. My radical graph will look something like that. So the y-intercept, I hope you see, is going to be different. Therefore, the answer is C.